So our next topic is all about integrating factors found by inspection. So reminder lang, hindi sa lahat ng pagkakataon ay spoon feeding. Meaning, kapag binigyan ka ng differential equation, hindi ilalagay doon na ang gamitin mo ay homogeneous, exact, linear, etc. There are times na kapag binigyan ka ng differential equation, problem lang talaga siya. Nasa sayo na yun kung anong technique yung gusto mong gamitin. So, dito naman sa topic na integrating factors found by inspection, ito yung matuturing na shortcut or easiest way para masolve yung ibang differential equation. Hindi naman to applicable lagi, pero kung applicable siya, masasabi natin ito yung pinakamagandang gamitin dahil mas mabilis ito. So, there are 5 frequently used integral combination. So, yung product rule, quotient rule, tsaka yung derivative ng inverse tan at derivative ng inverse hyperbolic tangent. So, mas maiintindihan natin yung application ng limang ito kapag dumako na tayo dun sa problems. So, again, as usual, meron ako ditong inihandang 6 problems. At isasolve natin ito isa-isa. Ipapakita ko sa inyo yung essence ng integrating factors found by inspection at kung bakit kailangan ma-master nyo ito lalo na kapag dumako na kayo sa pag-take ng subject na ito. So let's proceed to number 1. X plus y dx plus x minus y dy is equal to 0. So gagamitin muna natin yung ibang technique bago ko ipakita yung sa inspection para makita nyo yung differences ng dalawa. So in this case, gagamitin natin yung homogeneous. So in-expect ko na napanood nyo na yung homogeneous equation video na yung link ay nasa baba. So, let's proceed. So, in this case, pwede natin sabihin x is equal to vy. Parang dx natin ay magiging v dy plus y dv. So, substitute lang natin sa equation. So, magiging by plus y times yung dx natin, which is yung v dy plus y dv plus vy minus y dy is equal to 0. So, pwede natin i-divide yung equation sa y. So, ang matitira na lang is v plus 1 v dy plus y dv plus v minus 1 dy is equal to 0. So, dinivide lang natin siya sa y. Kaya naging ganito yung sagot. So, simplify na natin, distribute lang natin. So, magiging b squared plus b dy plus v plus 1 b plus 1 plus y dv plus v minus 1 dy is equal to 0. So, ngayon, pwede na natin pagsama-samahin yung lahat ng dy at iwalay natin siya sa dv. So, in this case, magiging b squared plus v is yung dy natin, which is yung plus b minus 1. So, plus v minus 1 dy plus v plus 1 y dv is equal to 0. So, simplify lang natin tong equation, yung nandito sa equation na ito. So, ang mangyayari is b squared plus 2v minus 1 dy plus b plus 1 y dv is equal to 0. So, pwede na tayong mag-variable separable. So, in this case, ang mangyayari sa kanya ay magiging divide lang natin siya sa y tsaka sa b squared plus 2b minus 1. So, ang matitira sa equation is dy over y plus v plus 1 dv all over b squared plus 2b minus 1 is equal to 0. So, pwede na tayong mag-integrate. So, integration. So, dito, wala namang kaso to kasi may direct integration na siya. So, dito na muna tayo. So, dito pwede tayong mag-u sub. So, ilet natin ng u, yung b squared plus 2b minus 1. So, magiging du natin is 2b plus 2 dv. So, pwede nating sabihin, ang magiging du na natin is 2 times b plus 1 dv. So, kuha natin yung value ng dB, which is yung du over 2b plus 1. So, substitute na natin to sa equation. So, pagpatuloy, so, mangyayari na is integration ng dy over y plus integration ng b plus 1. So, ito lang yun. Ito lang yun. So, b plus 1, substitute natin yung value ng dv, which is du over 2 times b plus 1. So, times du over 2 times b plus 1 all over u, which dahil sinab na natin siya as u. So, all over u is equal to integration ng 0. So, matatanggal itong b plus 1, b plus 1. So, magiging 1 half du over u na lang to. So, may direct integration na. So, let's proceed na dun sa integration. So, magiging ln y plus 1 half ng ln u is equal to ln c. So, i-multiply lang natin lahat sa 2. So, magiging ln y squared plus ln u is equal to ln c. So, magiging i-substitute na natin yung value ng u, which is yung b squared plus 2b minus 1. So, ln y squared plus ln ng b squared plus 2b minus 1 is equal to ln c. So, yung sa multiplication rule ng logarithm, so magiging ln ng y squared times b squared plus 2b minus 1 is equal to ln c. Pwede na natin tanggalin yung ln since meron naman siya left at saka right side ng equation. Then, substitute na natin yung value ng b. So, kanina, balik lang tayo, nilit natin yung x equal to by. So, ang magiging v natin, so dito yan. So, ang magiging v na natin is x over y. So, substitute na natin siya dito sa equation. So, matatanggal na yung ln. So, magiging y squared times y squared over x squared. So, x over y lang yan na naka-squared. Plus 2x all over y minus 1 is equal to c. So, solve pa natin itong nasa loob. So, maging y squared. So, LCD niya lang. So, y squared x squared plus 2xy. So, dito minus y squared is equal to c. So, matatanggal na to. Tatanggal na to. So, magiging final answer natin is x squared plus 2xy minus y squared is equal to c. So, ito yung final answer natin kapag homogeneous yung ginamit natin. So, i-try naman natin kapag inspection. Kapag nag-solve tayo ng problem involving inspection, so, i-distribute muna natin siya para mas madali nating makita yung itsura ng equation. So, in this case, x dx plus y dx plus x dy minus y dy is equal to 0. So, inspect natin yung equation. So, makikita natin na pwede natin pagsamahan yung y dx tsaka x dy. Bakit? Kasi diba, ang derivative ng xy ay gaya nandun sa frequently used integral combination na x dy plus y dx. So, pwede nating ipalit ito dito. So, ang magiging equation na lang natin is x dx plus derivative ng xy minus y dy is equal to 0. So, pwede na tayong mag-proceed agad sa direct integration. So, integrate lang natin to, integrate lang natin to, integrate lang natin to. So, ang derivative ng x natin is x squared over 2 plus, kapag in-integrate natin yung derivative, ang sagot is yung nasa loob ng derivative. So, as easy as that. So, ang integration ng derivative ng xy is xy minus y squared over 2 is equal to c. So, pwede nga natin sabing c over 2 yan eh. Constant pa rin naman yan eh. So, i-multiply natin itong both equations sa 2. So, magiging final answer natin is x squared plus 2xy minus y squared is equal to c. So, ito na yung final answer. Ganun lang siya kadali na solve sa inspection. So, compare natin sa sagot natin kanina. Ito yung ginamit natin yung homogeneous. So, pares lang sila. So, ang pinagkaiba lang nila, mas madali natin na solve kung gagamit tayo ng inspection. So, for number 2, 2xy minus e raised to y dx plus x times x minus e raised to y dy is equal to 0. So, in this case, i-distribute muna uli natin siya. So, magiging 2xy dx minus e raised to y dx plus x squared dy minus x e raised to y dy is equal to 0. So, inspect natin yung differential equation. So, ano yung pwede nating pagsamahin? So, in this case, pareha silang may e raised to y. So, possible na pwede silang i-combine. So, kasi hindi tayo dapat nagbe-basis lang dun sa 5 ginamit ko na frequently used integral combination. Dapat marunong din tayo mag-create ng sarili nating combination kapag nagsusolve tayo gamit yung inspection. So, in this case, pwede natin itong pagsamahin dalawang to. Ito rin, pwede natin pagsamahin. So, ang gawin natin is pagsamahin natin sila 2xy dx plus x squared dy. So, ito naman dalawa, magiging negative e raised to y dx minus x e raised to y dy is equal to 0. Then, create na tayo ng integral combination natin. So, in this case, masasabi natin na ang derivative ng x squared y ay, so left the right plus right the left. So, left y times yung derivative nito, which is yung 2x dx plus x squared dy. So, 2xy dx plus x squared dy. So, ito yun. So, pwede na natin i-substitute itong dx squared y dito sa equation na ito. So, dito naman, masasabi natin na yung derivative ng ito lang, kahit x e raised to y lang, makikita mo naman yan pag nag-derive na eh. So, derivative ng x e raised to y. So, ang derivative niyan is e raised to y dx plus, so, x, derivative ng e raised to y. So, alam naman natin na derivative ng e raised to y is just e raised to y dy. So, pwede natin itong i-substitute dito naman sa dalawang to. So, ang mangyayari na lang sa equation natin is derivative ng x squared y minus. So, dapat diba plus. So, ilabas natin yung negative sign. So, magiging derivative na siya ng x e raised to y is equal to 0. So, pwede natin siyang integrate. So, magiging final answer natin is x squared y minus x e raised to y is equal to c. So, pwede natin ilabas yung x. So, magiging x y minus e raised to y is equal to c. So, ito na yung final answer natin. So, ganun lang siya kadali kapag gumagamit tayo ng inspection. So, number 3, e raised to x y squared cos y plus x dy plus e raised to x y squared sin y minus y dx is equal to 0. So again, i-distribute lang natin siya. So magiging e raised to x y squared cosine y dy plus x dy plus e raised to x y squared sin y dx minus y dx is equal to 0. Now, let's proceed to inspection. So, mapapansin natin na may relationship itong part na equation na ito, tsaka ito. So, alam naman natin na ang derivative ng e raised to x sin y is just e raised to x, derivative ng sin y, which is cosine y dy plus sin y, derivative ng e raised to x, which is e raised to x dx. So, makikita natin siya dito na e raised to x cos y dy plus e raised to x sin y dx. So, ang problema lang is pareho silang may y squared. In that case, pwede natin i-divide yung equation sa y squared. So, ang kalalabasan niya na is e raised to x cosine y dy plus e raised to x sin y dx plus x dy minus y dx all over y squared is equal to 0. So, dito sa part na to, nakaform na tayo ng integral combination. So, proceed naman tayo dito sa part na ito. So, quotient rule lang. So, alam naman natin na ang derivative ng x over y, yes, y squared over low d high minus high derivative ng low. Problema, baligtad sila. So, in that case, pwede naman nating i-shift yung sign niya sa labas. So, paano yun? So, magiging e raised to x cos y dy plus e raised to x sin y dx minus, so, lagyan natin ng parenthesis. So, y dx minus x dy all over y squared is equal to 0. So, proceed na tayo sa integration. So, ang kalabasan niya is integration ng derivative ng ex sin y minus integration ng derivative ng x over y is equal to integration ng 0. So, ang final answer is e raised to x sin y minus x over y is equal to c. So, ito na yung final answer. Number 4, 2xy minus y squared sin y dx minus x squared plus xy squared cos y dy is equal to 0. So, i-distribute lang natin siya. So, magiging 2xy dx minus y squared sin y dx minus x squared dy minus xy squared cos y dy is equal to 0. So, inspect natin yung equation. So, kapag nag-inspect tayo ng equation, pwede na agad tayo makabuo ng integral combination sa isip natin. So, dito, itong dalawang part ng equation na ito, seems like meron silang relationship. So, pwede nating sabihin na yung derivative ng x sin y ay x cos y dy plus sin y dx. So, dito sin y dx, tapos dito x cos y dy. So, napalabas natin siya. Ang problema lang, may y squared sila parehas. So, in that case, pwede natin i-divide yung equation sa y squared. So, ang kalalabasan niya na ngayon is yung 2xy dx minus, pagsamahin, ilagay na natin ito dito. So, x squared dy, so dinivide natin siya sa y squared, minus, so since parehas naman sila minus, ilabas lang natin yung negative sign, so magiging sin y dx plus x cos y dy is equal to 0. So, may integral combination na tayo na nabuo dito. So, dito naman tayo sa 2xy dx minus x squared dy all over y squared. So, kamukha siya nung sa quotient rule natin. So, pwede natin yung gamitin. So, alam naman natin na quotient rule, since naka-square niya is yung y sa denominator, so y nasa denominator. So, low d high minus high d low. So, there is change in x. So, ibig sabihin, na-derive yung numerator. So, yung 2x na to, so, dati, x squared yan. Kasi nga, di ba, x squared, kapag dinerive natin yan is 2x dx. Tapos yung denominator natin is 1. So, denominator natin is y. So, y, derivative ng high, which is yung x squared, 2x dx. So, ang lumabas is 2xy dx. So, x squared, y. Kasi minus high, x squared, derivative ng low, which is yung y. So, x squared y. So, ito yung lumabas na integral combination natin. So, minus, so dito nakapag-create na tayo. So, derivative ng x sin y is equal to 0. So, pwede na tayo mag-proceed sa integration. So, final answer natin is x squared y over y minus x sin y is equal to c. So, pwedeng sabihin na ito na yung final answer natin. For number 5, x dy minus y dx is equal to x squared plus y squared e raised to x dx. So, pwede nating i-divide yung equation sa x squared plus y squared. Bakit? Kasi yung sa kanina, yung frequently used integral combination natin, alam natin na ang derivative ng inverse tan ng y over x is x dy minus y dx all over x squared plus y squared. So, pakita ko lang. So, ang derivative ng inverse tan ng y over x is x dy minus y dx all over x squared plus y squared. So, pwede nating i-apply to dito sa number 5. So, i-divide na natin yung equation sa x squared plus y squared. So, magiging x dy minus y dx all over x squared plus y squared is equal to e raised to x dx. So, pwede natin siyang gamitan ng integral combination. So, magiging derivative ng inverse tangent ng y over x is equal to e raised to x dx. So, integrate na natin. So, may direct integration naman tong e raised to x. So, ang mangyaring sagot na natin ngayon is derivative ng integral ng derivative ng inverse tangent ng y over x is yung nasa loob niya, which is yung inverse tangent ng y over x is equal to integration ng e raised to x dx is e raised to x plus c. So, yung final answer natin is inverse tan ng y over x minus e raised to x is equal to c. So, ito na yung final answer natin para sa number 5. Number 6, dy over dx plus y over x is equal to 2e raised to xy. So, in this case, pwede natin kunin yung LCD nito, which is x dx over x dy plus y dx is equal to 2e raised to xy. Yan. Tapos, cross multiply lang natin. So, magiging x dy plus y dx is equal to 2e raised to xy x dx. So, again, inspect lang natin yung equation. So, dito, para ma-solve natin tong equation dito sa part na to, pwede tayong mag-u-sub. So, ilet natin ng u, which is yung mas taas niya, which is yung xy. So, mag-a-arrive tayo sa du na x dy plus y dx. So, substitute lang natin sa equation. So, x dy plus y dx is du. So, du is equal to 2e raised to u x dx. So, variable separable na siya. So, ilipat lang natin to dito. So, magiging e raised to negative u du is equal to 2x dx. So, solving the equation, so, ang derivative ng e raised to negative u, integral ng e raised to negative u du is just negative e raised to negative u is equal to x squared plus c. So, substitute na natin yung value ng u, which is yung xy. So, maging negative e raised to negative xy is equal to x squared plus c. So, ito na yung final answer natin.